Hey, hi. In this video, I will show you how an AWS SNS topic will invoke the AWS Lambda function through a SQS service. Okay, so that's a big demo indeed. Yeah. So whereas the first part, that is setting the AWS SNS infrastructure, has been already been done. Okay, so that is being done in a separate video. Please do watch my previous video in regards to how you can set up the AWS SNS infrastructure, which will in turn invoke the AWS Lambda function. Okay, so please do watch my previous video where I have explained everything from the scratch in regards to this one. And also kindly please do subscribe my channel. That would really encourage me a lot. Okay, so with that note, let's get started to this demo. Yeah, so let me give a brief about this demo. So in this demo, I will show you is I will show you that the whenever a message gets published to AWS SNS topic, yeah, then automatically that will publish as a queue message to AWS SQS service. Okay, which in turn will invoke our AWS Lambda function. Okay, so that's a big big chain kind of invocation will happen. Yeah, so that's the reason I have divided this big automation in two parts. Okay, in the first part I have explained like how you can set up the AWS SQS and AWS SNS services, which together can work to publish queue messages at the end. Yeah, so that has been already been shown in the other videos. Okay, so this is the continuation of the same video. Yeah, so before I walk you through the code of the second part, that is the how you can create the AWS Lambda function and also make a connection between the AWS SQS service so that it can invoke the AWS Lambda function. Okay, so before I walk you through the code, let me quickly give a brief about this demo in the format of a picture. Yeah, so I just see in my screen. So this is the pictorial representation of this demo. Yeah, so here you go. So here it has two big logos. One is the GitHub account and other one is the AWS account. Yeah, AWS logo. So under GitHub account we will be having GitHub repo and GitHub Actions. Okay, which we will be doing in terms the CI/CD task. Yeah, and also under the AWS account we will be having SNS. Okay, so SNS is nothing but AWS simple notification service. Okay, and in that simple notification service we have created a topic and also created a subscription to that topic. Okay, so and whenever the messages gets pushed to that SNS service, then automatically that message will be published to AWS SQS service. That is again a queue service. Okay, that is the simple queue services from AWS. Okay, so whenever the message comes and sits in the AWS SQS service, then automatically our Lambda functions will gets invoked. Okay, so that is like a big connection has been done in this terms. Yeah, so whenever a queue comes and sits in our SQ service, then automatically our AWS Lambda function will be gets invoked. Okay, once the AWS Lambda functions get successfully ran, then it will log an event in our CloudWatch logs. Okay, so this is the complete chain kind of automation which I will be showing you. Yeah, we have developed this complete infrastructure using the Terraform. Okay, whereas the first part includes SNS and SQL service infrastructure setup that has been explained in the previous videos. Okay, please watch that. Yeah, before you come to this video. Yeah, and also here we will be taking the other part, that is the setting the connection between AWS SQS, which in turn invokes the AWS Lambda function and also finally registers an event in the CloudWatch logs. Yeah, so that kind of demo I will be focusing on in this one demo. Okay, so with that note, let's get started to our code walkthrough. Okay, so probably before I go to the code walkthrough, so let me tell you that the how the pipeline works here. Yeah, so first one, I will be developing my code in the Visual Studio Code, where I will be publishing the code to my GitHub repo, which is under GitHub account. Yeah. Again, so whenever I pushes the code to my GitHub repos, then automatically the respective GitHub actions will be invoked. I have Terraform apply and the Terraform plan GitHub actions. Okay, which will in turn and set our complete infrastructure. That is the complete event-driven infrastructure, right? Event-driven automation infrastructure in the AWS account. Okay, so that's what the demo shows about. Yeah. So with that note, let's get started to this code walkthrough of this demo. Yeah. Here you go. As I said, like I have my complete infrastructure ready here. Okay, like I have the Visual Studio Code. In that one, I have cloned my repo. Yeah, in that repo I have the two branches. One is the feature branch one, and also I have other branch, that is the main branch one. Yeah, so feature branch one, again, as I tell every time, this is a development branch where I will be doing my development task. Okay, and also the main branch. So main branch I denote it as a production branch through which I will be doing the Terraform apply GitHub Actions. Okay, yeah. So here it contains two GitHub Actions. Okay, that is the Terraform apply and the Terraform plan. Okay, the Terraform plan will be pointing to only to future branch one, where we will be seeing the Terraform plan summaries. Yeah, and also we have the Terraform apply. The Terraform apply is meant to actually provision the required infrastructure in the AWS account. Okay, so that's what the our GitHub Actions file says about. And also under the root I have the one folder called Lambda. Okay, as the name says, it contains the Lambda, the business logic. Nothing, when I say business logic, nothing but it contains the function definition, Lambda function definition. Okay, so for this demo I have created the node.js Lambda function. Okay, this is the example node.js Lambda function. Okay, where it just invokes the handler function. Yeah, handler block, and it will just return the success message. Okay, that's what it does. It's a basic node.js function. Yeah, node.js Lambda function. Okay, and so this is all about the logic of the Lambda function. Yeah, and after that I have the AWS SNS.terraform file. So this is the Terraform file which sets up the complete SNS infrastructure. Okay, which includes an SNS service, and also SNS service is being configured to push the queues message to the queue. That is our AWS SQS service. Okay, so that infrastructure has been written in this one. And also one more time, let me remind you that I have explained this infrastructure in the previous video. Yeah, please do watch that video so that you will connect the dots. Okay, yeah. And finally I have one more function, that is the Lambda, that is lambda.terraform file. Okay, this is the file which contains the end-to-end definition about this demo. Okay, so when I say this demo, what I'm doing is I'm making a connection between the AWS SQS service to AWS Lambda function. Okay, whenever the queue comes in search in the AWS SQS service, then automatically my Lambda function will get invoked. Okay, so that kind of configuration has been defined in this Terraform file, and I will be focusing only to this Terraform file only. Okay, yeah. So, and also I have one more file, that is main.terraform file. Is it contains Terraform backend configuration, and also the required Terraform provider configuration. Yeah. So with that note, I have given you brief about the files of this demo. Okay, so as we are focusing in this video in regards to the how we can invoke the AWS Lambda function from the SQL service, that is indirectly it will be invoked by the AWS SQL service. Okay, so that kind of configuration has been defined in this Terraform file. I will just quickly walk you through and I'll show you the demo as well. Yeah. So here, what I'm doing is I'm creating the zip of the Lambda folder. Okay, so Lambda, when I say Lambda folder, under Lambda folder, I have the only one function, that is an example Node.js function. Okay, so I'm creating an archive file of that .js file. Yeah, so this is the block which does that. That is the data. It starts with the data. It's an archive file. That is archive underscore file is the resource type to do the archive file. Yeah, and this is the variable. Inside this flower bracket block, we are giving the required parameter. One is the type, the source file. Here you go, the source file is nothing but it is pointing to the same node.js file, nothing but this file. Yeah, and the output path, so I'm dynamically creating the output path, and it will be the zip file. Okay, the zip file will be stored in the same folder, that is the Lambda folder. Yeah, so that's about the archival step. Yeah, and the next one I'm creating an S3 AWS S3 bucket. Okay, so this is the block which creates an example as the AWS S3 bucket, where I will be storing this .zip file. Okay, so that I can use this during the AWS Lambda creation. Yeah, so let me quickly walk you through this one as well. Again, the S3 bucket is a resource. Yeah, it starts with a resource. This is the resource type, that is AWS underscore S3 underscore bucket. This is the variable, yeah, of this block. And inside this flower bucket block, we are giving the bucket name. So this is my bucket name, ACL. So this is the access control list. Yeah, and the tag name is this is my bucket name. Okay, and after that, once the bucket is got created, I'm uploading an object to that bucket. Okay, so this is the block which does that. So again, it's a resource. So we are using the AWS underscore S3 underscore bucket underscore object. So we are creating an object inside that bucket. Yeah, and this is the object is the variable name of this block. And inside this flower bracket block, we are giving the required parameter. One is the bucket name. So this is the bucket name is nothing but it is pointing to the same bucket which we created above. Yeah, and the key, this is the key time, so nothing but the file name or the folder name. So this is the file name which I'm keeping it here. And the source, as you see here, the source is nothing but the path which where the zip file will be created, right? So it is pointing to there. So it will retrieve that zip file and it will push it under the AWS S3 bucket on. Yeah, so that's what this block does. Next one, so I'm creating the required AWS Lambda function, which we are targeting to show the demo. Yeah. So this is the Lambda function, which this is the code block which creates the AWS Lambda function. Okay. Again, it's a resource, and this is the resource type, that is AWS underscore Lambda underscore function. Yeah. This is the variable of this Lambda, this code block, this block. Yeah. This is the variable. Yeah. Inside this flower bucket block, we are giving the parameter. One is the function name. So this is my function name, that is small letter example. Yeah. And the bucket, this is the bucket id, nothing but why I'm giving the bucket id is because from there the function app, whenever the function app is getting whenever the lambda function gets created, so whenever the lambda functions gets created, so automatically that zip file will be taken as a source code of this lambda function, and automatically the lambda function will be provisioned based on that zip file only. Yeah, so that's the reason we are giving the reference to that bucket, and the key s3 key which we are using is example.zip file. Okay, yeah. So nothing but the same zip file which I have uploaded at the S3 bucket. And the role. So we are using one role to this function. So that role will be defined below. So I will go walk you through that one as well. So henceforth we are referencing the same role here as well. Yeah. And the handler here, the handler points to the example dot handler. Yeah. And the runtime is the Node.js 1. Node.js 1.2.x. Yeah. So that is the Node.js version. Okay. Since we are creating a Node.js Lambda function. Okay. And the next one is the AWS IAM role for the Lambda. Yeah. So again, it's a resource, and the resource type is AWS underscore IAM underscore role. So this is the resource variable. Inside this flower bucket block, we are giving the required parameter. One is the name of the IAM role and the assume policy. Okay, the assume underscore role underscore policy. Okay, it's starting with the smaller than EOP and ends with EOP. Yeah. So inside this, we will be having a JSON function. Okay, so this is the JSON body. Okay, inside this we are just assuming the role. Okay, so let me tell you that this is the where we are assuming, that's the, yeah. So we are allowing the assume role to our service principal of our lambda function. Yeah, so lambda service. Yeah. And after that we are attaching a SQS policy. Okay, this is the block which attaches a SQS policy to that above rule. Okay, so let me quickly walk you through this row, this IAM role policy as well. So this is again a resource, and this is the resource type AWS underscore IAM underscore role underscore policy. Yeah, so this is the resource type for that. This is the variable. Inside this flower bucket block, we are giving the parameter, that is the name. The role is again pointing to the same role which we have created above, and it is referencing to the ID. Yeah. And inside this EOP block, that is policy, is again a EOP block. Yeah. So here where we are allowing the required actions. Okay, that is the change message visibility, delete message, get queue attribute. Yeah. Then the resume message. Okay, so effect is allow, and the resources everything. Yeah, so that's what. And finally we are also attaching one more policy which is meant to read the logs. Okay, yeah, so nothing but from the cloud watch we need to view the logs. Okay, that's the reason we are allowing this policy as well. Yeah, so that the lambda function can publish the logs to the cloud watch. Okay, so that's the reason this policy is very important for that purpose. Okay, so here again it's a IAM role policy, and this is the variable for it. Yeah. And inside this flower bucket block, we are giving the required parameter. One is the name of the policy, the role, and the EOP block. Inside this EOP block, if you see, right, we are allowing the certain actions, that is the create log group, create log streams, and the put log puts. Okay, nothing but, so we are giving the lambda functions a certain roles. Okay, we are allowing the certain permissions to the lambda function so that it can publish the logs to the cloud watch. Yeah, yeah. And so then finally we have one more block, so where we I'm just retrieving the what is the my primary AWS SQS service. Okay, this SQS service has been created in the previous demo. Okay, previous video. Yeah, please do, I again highly recommend you to please do watch the previous video, then you will be understanding this. Yeah, this demo as well. So here again this is the data block where I'm just retrieving the required attributes of my AWS SQS service. Henceforth, this is the resource type, that is AWS underscore SQS underscore Q, and this is the variable. Yeah, inside this flower bucket block we are giving the only one parameter, that is a name. Okay, this is my name of my SQL service. Okay, which will publish which will automatically invoke my AWS Lambda function whenever the queue comes and sits in this one. Yeah. Then finally, how the what is the connection between the queue service, this queue service, and the Lambda function which we created above. So that connection will be set up by this block. Okay, this block is very important. Okay, let me make a note. So this is again a resource. Okay, and this is the resource type which does that, nothing but So AWS Lambda event source mapping. So nothing but we are mapping the event source. Okay, as you know that the Lambda function will be invoked at every event. Okay, so somebody has to source that event, right? So that's where mapping is happening here. Okay, it's a simple readable format. That is AWS Lambda event source. AWS underscore Lambda underscore event underscore source underscore mapping. So we are mapping the event source to our Lambda. Yeah, and this is the resource type. Yeah, this is the variable. Yeah, inside this flower bucket block we are giving the required parameter, that is the event source arn. Okay, so we need event source arn, so the arn will be referencing to the same SQS service. Okay, because the event source is our queue service. Okay, so again this is the data and this is the resource type, this is the variable. Yeah, it's pointing to the same data. Yeah, and arn is been the attribute which is consumed here, which will be consumed here. Yeah, and this is the function name. This function name is nothing but the same function which we created just above. Okay, so where the arn is been referenced. Okay, so that's it. We have successfully walked you through the complete code code in Terraform, which makes the connection between the AWS SNS service, which in turn will publish a queue to the our SQS service, and that SQS service will in turn will cause, okay, that will be responsible for creating or invoking the our AWS Lambda function. Okay, so that's what this complete demo is. Okay, so this code I have already published to my AWS. I have already published to my GitHub account. Okay, from there the Terraform plan and Terraform apply has already been invoked. Okay, so let me show you that. So let me go to my repo. So first, okay, this is my repo. Yeah. So inside this repo, I have two branches as I explained earlier. That's a main and a future branch one. Yeah. So once I made those changes and published the changes to my upstream branch, nothing but to my GitHub account. Yeah. So my GitHub Actions has been already been invoked. Okay. So let me quickly walk you through those logs as well. So here you go. I have the two pipeline, that is the Terraform plan and the Terraform apply as well. Yeah. So under the Terraform plan, okay, so it has already ran. Okay. And so during the connection creation, so what are the resources it got created? Okay. So let me show you that. So if I expand the Terraform plan, so what the log says is so it has successfully mapped it. Okay, so as I explained, like I have already created the AWS SNS infrastructure, right? So then I'm creating the mapping, right? So that mapping has been created here. Okay, so that's what the log says. Yeah. So finally, the once the connection has been established from the Lambda function and the SQL service, then automatically the automation has been established. Okay, then automatically the Lambda function gets invoked automatically whenever the queue comes and sits in the SQL service. Okay, so that's about the Terraform plan logs. So let me quickly walk you through the Terraform apply logs as well. Yeah. So this is the Terraform apply. Yeah, this is the Terraform apply GitHub action. So this is the GitHub action. So let's quickly walk you through the logs of the Terraform apply as well. Yeah. So under this Terraform apply, let's see what are the resources got created. Yeah. So here you go. It has successfully created the required infrastructure. Okay. Finally, it has established the mapping, right? So that's what the log says. Okay. It has successfully they established the mapping, right? That is the event source mapping. That is mapping between the SQS to AWS Lambda. Okay. So that's what the Terraform apply log says even. Yeah. Now it is time to go and see the infrastructure has been provisioned as expected or not. Okay. So first one, let me show you the if the S3 bucket are being created or not. Okay. So I'm going to the S3 bucket and let me show you that the required S3 bucket has been created and it also has the object. Yeah. So it's currently loading in. So and let me take you to the my bucket. Yeah. So this is the bucket which I have created. Yeah. And inside this bucket, I have the example.zip file as an object. Okay. So that's what been already been done. Okay. One topic is already been created. Now, then let me show you that if the Lambda has been created. Okay. The Lambda which I have published, right, through the Terraform. Yeah. So I will take you to this AWS Lambda. Here you go. The AWS Lambda, that is the example. Okay. So this is the example Lambda. Okay. So that's the function name. That's my function name. Yeah. So let me go to the code and show you that it has the Node.js function as well. Yeah. I need to open this. So let me click and open it. Yeah. So here you go. Yeah. So this is the example that dot JSON file, sorry, example dot JS Node.js file, which we have published, and the same is been sitting here in the AWS Lambda function. Yeah. Okay, so that we are also good with the Lambda function as well. So let's see the our SQNS and SQS services as well. Yeah. So in regards to this one, again, I would recommend you to please do watch my previous videos to how to set up this infrastructure. Okay. So for this demo, I'm just quickly walking through. So this is the topic which I have created. I will be publishing one example message to show you that the our Lambda function gets invoked automatically. Yeah. So this is the our SNS topic. Okay, and it also has a subscription. Okay, and that subscription will push in turn push a queue message to our SQS service. Okay. So let me take you to the SQS service as well. So here is the SQS service. Under SQS service, I have two types of SQS. Okay, one is meant for dead letter queuing. So dead letter queuing, one kind of queue, and another one is the primary queue. That is the primary queue which actually receives the queue messages. Okay, so that's all about the our complete infrastructure. Okay, finally I have the CloudWatch. Okay, from where I can show you the logs as well. Yeah. So let's go to the demo. So let's quickly walk to the demo. Yeah. So for to start the demo, as you know that the pipeline starts here starts from the SNS service. Okay, nothing but simple notification service. Okay, and under the simple notification service, a resource can be anything. Okay, the resource will come and publish a message to their particular topic. Okay, so let's do that. So for this demo, I will manually publish a image, publish a message to our SQS, to our SNS topic. Okay, whereas at the real time, so some machine or some services or some application will be publishing a message to this topic. Okay, in real time. Yeah, so that's what I mean. So let me publish a example message. So let me say it is as a quick. So let me call it as a cloud quick POCs. Yeah, which where the demo source of yeah. Um, so that's the just a subject matter, yeah, subject of this this demo. Yeah, and just let me type test demo CQ POCs. Yeah, so I am now currently what I'm doing is I'm publishing this message, okay, to the SNS topic. Okay, so again let me tell you that since I'm manually publishing a message to our SNS topic, in real time it can be anything, right? It can be an application, a service, or a device, okay, which can publish a message to this SNS topic. Yeah, so as you can see, the message has been successfully published to this topic. Okay, let's directly go to the our CloudWatch. Okay, because it's a very fast service, so that the what it next since the integration is very fast, that once we publish a message to the our SNS service, then automatically the queue will be created, and that queue will in turn invoke our AWS Lambda function. Okay, so let's see that whether that has successfully happened from the CloudWatch logs. Okay, so I need to go to the logs and I need to choose the logs.groups. Okay, if I go to the logs.groups, I should see one group has been created. Okay, so as you see here, AWS Lambda. So this is my Lambda. That is the example Lambda which I have created. Right? I have shown you that there. So that log group has been created. Okay, so let's see if our message has been reached here. Okay, here you go, the message has been successfully reached just now. Yeah, yeah. So let me show you that whether the message has been received and it is being processed by our AWS Lambda function. Okay, indeed it has happened. So let me show you by the message. Okay, if you remember correctly, we have given some message something like that. Okay, where the subject was cloud quick POCs and the message is test demo CQ POCs. Yeah, so that's it. Our message has, see, I have not invoked the AWS Lambda function, but Q has made it to invoke our Lambda function. Okay, so that's what this is, the complete automation has been achieved now. Okay, we have not invoked the Lambda function, but automation, right? Our queue message came there, and it automatically it invoked the AWS Lambda function. Okay, so that's where the end-to-end automation has been achieved now. Okay, so that's it. We have successfully shown you that how you can create the AWS SNS infrastructure, which in turn will publish a queue message to the AWS SQS service. Okay, whenever the AWS SQS service receives a queue message, then automatically it will invoke our AWS Lambda function, which is nothing but a business computation, I can say. This is where the business computation happened, right? So that is the AWS Lambda will process the queue message, and it will do the real business function. Okay, yeah. So that's it. We have completed this demo by this. Yeah. Once again, thank you for watching our videos. A kind request, and also a kind request, please do subscribe my channel. That would really encourage me a lot. Okay. With that note, thank you. Thanks a lot.